All right, we're going to do two questions. The first one's in 5.3, page 379, number 16, and then after we're going to do page 384, number 3. So this question's worded kind of weird, so we're going to take it one step at a time. The length of a rectangle is 4 times a number. So we got length and width of a rectangle. So I'm just going to draw a rectangle so you kind of understand. That's the length, that's the width. And it said the length is greater than the width. So the length is bigger than the width. So now it says the length is 4 times a number. So let's call that length for y, whatever. Okay? Then it says the width of the rectangle is 3 less than the square of another number, a different number. So I'm going to write that as 3 less means minus 3, then the square of another number, so like x squared. Okay? And because it said the length is greater than the width, so I'm going to say length is greater than width, but instead of length and width, I'm going to write in the dimensions we just came up with. So length is 4y, and width is x squared minus 3. So looking at that, we now have a quadratic inequality, which is what the unit's called, okay? But I don't really like that 4 being there, so I'm going to divide everything by 4. It's going to give us decimals, that's okay. If you want to do these fractions, that works too. So I'm going to get y is greater than 0.25 x squared minus, what's that, 0.75. Okay? Right there, that's our equation. So now it says sketch a graph to represent the situation. So to graph it, I'm going to use vertex form. It's probably the easiest. My scale is going to have to be pretty small. Yeah, let's do that. Okay, so because we got like decimals going on, I'm probably going to make my scale go up by like quarters. All right, so looking at this is vertex form. It has no horizontal shift, and a negative shift is 0.75. So if we were just going to draw this actually freehand, so like this is 1, 2, negative 1, negative 2, 1, and 2. Okay, my vertex is going to be here. Let's make it red so we can see it at 0.75. Okay, and the stretch, normally we would use the step method to go over 1, up 1, but because it is multiplied by 0.125, so it's over 1, up 1, over 1, up 3, 5. Okay, it's going to be over 1, up a quarter, over 1, up 3/4, over 1, up 5/4. Okay, so it's going to be kind of hard to see on the scale. So it's going to go over 1, up 0.25, which will bring me to half, and then over 1, up 0.75, which brings me to 1.25, and then over 1, up 1.25, which brings me to 1.5 there. Okay, we can get our mirrors going. If you want to draw this a little more to scale, you totally can. You can use Desmos if you want to see the exact details, but I have my basic graph going there. Because the symbol was greater than, I'm going to draw a dotted line. Okay, so we can see it. And then the other part is we have to shade it. So we would normally be shading everything above it. The only thing we have to be careful of is here we have some negative values. So we can't actually include those values in the graph because you can't have negative y values. That wouldn't make any sense because you'd have like a negative length. So we're going to shade everything that's positive, which is basically from here onwards. So it's going to be, I'll shade with highlighter. Okay, so it's like here and here. Basically all of it that is above the line, that is above the x-intercepts, above the y-axis, the x-axis, sorry. Okay, that's my sketched graph. The second part of the question says use the graph to list 3 possible sets of dimensions for the rectangle. So basically what you're going to do is looking at this graph, we just basically have to find any points that are in this area that would work. So like that is a point, that is a point, that is a point. There's an infinite number of points that would make sense. So like let's take one that I just randomly picked out right here, okay? So that point would be, what is that? 3, 3. So those would be my x and y values. So let's sub that into the actual equation so we can find the numbers. Okay, this was 4 times 3 because the y value is 3, and this is 3 squared minus 3. So that's going to turn into what? 9 minus 3 is 6, and this is going to turn into 12. So my length and width for that would be 6 and 12. Again, you could pick different points and sub them in. And even here, we're going to get some negatives, but it wouldn't really matter. So like if we tried, let's do this one right here. Okay, that's -2 and 2. If we sub in that for x and y, because the x is squared in this, it's going to actually work out okay. So it's going to be 4 minus 3, so that's 1, and the width would be 4 times 8. Okay? So there's going to be a lot of possible answers, obviously, right? The graph just wants you to use a couple. Pick solid points that make sense. You could use fractions, but like why? There's so many decimal, whole numbers that you could use instead. This idea of using a graph to list possible solutions is really important, and it's one that a lot of kids have trouble with. Most kids can draw the graph. They're like, oh, I got this, okay. But they have trouble trying to understand that like there are tons of possibilities within that shaded region for all the possible answers. Cool. All right. Other question was this one. Farmer needs to enclose a minimum area 66 meters squared. One dimension of the pen is to be 1 meter less than twice the other dimension. So let's draw a graph just so we can, or a picture, so we can kind of understand. Let's say the one dimension of the pen, we'll call this like length and width. We'll say that the length is going to be, or sorry, the width, we're going to write as, what's it say, 1 meter less than twice the other dimension. There we go. Okay. So this side is the length, whatever it is. This side is double the length minus 1 to fit in with what it said in the question. Okay. So now it says create an inequality to represent this problem. Oh, here we go. The minimum area of 66. So to find area, we do length times width equals area. Okay. But we're going to sub in the numbers we know. The area is at least 66. So it says it might be greater than, or it could be equal to. So that means greater than or equal to. Length is still length, but width is going to be this weird 2L minus 1. Okay? So now we could actually expand this to make it a little bit easier to see. So this is going to be what? 2L squared minus L minus 66 is greater than or equal to 0. Okay? I'm going to turn these to x's just so that I don't get confused when I'm writing this question out and think they're 1s or something. All right? Now I have my inequality. Cool. Determine two possible sets of dimensions of the feeding pen. All right? So there's a couple ways that we could do this. I think the easiest way that we're going to do it is by finding out what the x-intercepts are. So we would factor it. Use quadratic formula or factor it to find out what they are, but that's how we could get the actual answers. I'm going to graph it on Desmos to make it easier to see. Okay, so we had 2x squared minus x minus 66 is less than or equal to 0. Sorry, greater than or equal to 0. Okay, so these are all the possible values for x. So looking at this graph, essentially x can be anything that's greater than 6 or anything that's less than -6. So obviously we can ignore the negative values because it's dimensions, so we can't have negative dimensions. So we're just going to look at these positive values, anything that's greater than or equal to 6. So let's take, for instance, x equals 6. That is one possible answer. So if we sub that in to our situations over here, we would know that the length is equal to 6 and the width is equal to, what's that? 12. 6 times 2 is 12 minus 1 is 11. If we did another one, so like a bigger one, if we did, say, x equals 7, the length would equal 7, and the width would equal double that, minus 1 is going to be 13. Okay, and we have two answers. So, like I said, I cheated and used Desmos to see what it was, but if you wanted to not cheat, you could use quadratic formula to find out what the intercepts are and go from there, or you could graph it. Either would work, doesn't matter to me. And that's it.